Now you will recall this famous equation from Einstein. This is some point of view, a summary of his work and the thing that inaugurated the atomic age. And you will remember the parts of it. E stands for energy and M for mass. So on the left side, either energy or power, and on the right side, mass, stuff, things, and those are equated. It's a kind of lopsided equation because something very large, c standing for the speed of light, is squared, so it's even larger. So what this means is that a little bit of mass can be converted into a whole lot of energy. That's the essence of nuclear power and atomic weapons. But for us, what we should perhaps dwell on is the equation, the strangeness of putting these things that seem to be completely distinct categories, putting them into an equation and making them convertible. On the right side, you have things, solid stuff, material, mass, reality. And on the other side, a thing which seems to be of a different order altogether: power, oomph, ability, motion. All of those things are associated with energy, and we tend to keep them separate. And for centuries of modern chemistry, they had been entirely separate, and this was a great principle. So that a normal chemical reaction does not destroy matter. It can produce energy, it can absorb energy. This comes from simply the rearrangement of matter, which persists as it, in different forms, that its basic form stays the same. The atoms survive through it all, even if some energy is produced by the rearrangement of atoms. That would be a chemical reaction. But an atomic power plant is different from, say, one that burns coal for precisely this reason, because the carbon in the coal in a regular power plant is still there. It's mixed with oxygen when it's burned. It's in a different arrangement, but all the stuff is still there, ultimately in the same form, the same atoms, before and after. But that's not so in the modern world with an atomic power plant. The elements of the plutonium, the actual atoms, a few of them go away and generate large amounts of energy, because in the modern world we understand these not as distinct categories, but that the one can be changed into the other. And this is what's on Heidegger's mind. What does it mean for us that suddenly we've come into a new world with advancements in technology that say even this basic distinction, that power is power and matter is matter, and that they, whatever else happens in the world, those two things remain distinct. That turns out not to be true. But then when we think of matter now, according to the best scientific ideas, what is it? In the pre-modern centuries, they accepted four elements: fire, earth, air, and water. So modern chemistry finds that hopelessly primitive and naive, but it is something that we find easy to understand, that water would be an element. Well, there's water everywhere. And there are differences. The salt water in the oceans is different from the fresh water in our rivers. It can be ice, it can be steam. We understand that it comes in different ways. If you have the water in your hometown, it tastes one way, but if you travel, the water suddenly tastes different. We understand that there are differences, and yet water seems constant all over the world. One of the foundations of life, that there is always water, and we know what it is. And In the modern centuries, that with the beginning of modern chemistry, we had to adjust that water is a compound. It's both hydrogen and oxygen. And those two things, common enough, are, at least from our experience, completely different from water. There's oxygen in the air. It's stuff we breathe. It's very important. The air, again, is an element that is important to our sense that we know how the world works and that this is a constant. That while air is different in different places, the element is essentially the same. The modern world comes to think, no, it's two components of the air which coming together make up water, which seems to someone without chemical training to be a substance of a completely different kind. A gas is not the same as a liquid. So in the modern century, we had to adjust that the things we seem to know and the things that make life understandable and the things that are constant to our experience that allow us to think about the changes and understand those changes in light of what stays the same. In the modern world, we had to adjust that view. It's not the elements of our experience, air and water, that are constant, but it's the atoms that science through chemistry has let us be aware of. And only scientists through laboratories can discover the existence of things that precisely correspond to what we call hydrogen or what we call oxygen. It's only the scientists who will let us know in the early modern centuries what the realities are. And they're different, but not too impossibly different from the things of our experience. It's certainly strange to think that hydrogen and oxygen, which just float about in the air and are breathed in and out, would come together and make water. But at least there's something solid, something unchangeable. And from that perspective, to go with earlier modern science, you seem to be moving backwards. Your experience turns out to be confused and not a good guide to how things really are. So modern science makes you move backward, but also pushes you forward. There are things that we can understand. We can understand basic chemistry. And that gives us something that we could say, well, that is solid. That will always stay the same. That will allow us to understand what things are. And knowing that what things are will then give limits to what we want to do. You can breathe air, you cannot breathe water. If you know what water is and how it works, you can make a boat to sail across the ocean. But it's important that you stay on the top side of it, where human beings can live, and not under the water where only fish can live. The modern science breaks down our traditional understanding, which trusts our experience to explain the world to us, but gives us something in its place, which perhaps promises to be a better understanding. But what shall we do when we've graduated into the atomic world, where a basic understanding that we'd had before the modern age, during the early modern age, that we understand what matter is, and we know its limits. That would be one of the things that early modern science showed us that perhaps earlier ages were confused about. Matter never goes away. If you burn something, you seem to destroy it, but the atoms in it are preserved. They're always there. So it seemed like we had an understanding of the world around us through knowing that matter had certain characteristics, and those were everlasting. Those would always be true. And it might take science to contradict your experience and show you those truths. But at least science would replace your naive experience with a stronger and more trustworthy truth. But what should we do now when it turns out that matter is not eternal? It's not impossible to destroy matter, but that it's converted into energy. This happens all the time. You can look up at the sky and see the sun and see the evidence of this happening, that the energy from the light all around us is produced by the destruction of matter in the sun. And this gives us a very simple question, and it is uncanny, to use Heidegger's words. It is weird and perplexing, and makes understanding impossible, to think that we can no longer say at bottom what things are. Some of our feeling of comfort in the world was destroyed when we went from the basic elements of our experience, fire, earth, air, and water, as the basics that were always there and might change, but would never go away, and were always in themselves the same, despite minor variations. Something was lost when we went from that to the early modern scientific world, where we were forced to accept that the things of our experience are not simple and everlasting, but are compounds of other things that are outside of our experience. We never experience hydrogen or oxygen. We can know what it's like to be out of breath and maybe to be suffocating underwater, and so we know the power and importance of oxygen, but we don't know it directly. We don't see it. We don't touch it. We know some of its effects and its importance, but we don't know it in the same way that we know water. So in the modern age, we had to give up some of our feeling of being comfortably at home. But now it seems that we live in an uncanny world where we have to give up all of our feeling of being comfortably at home. We know that matter is energy and energy is matter. So what is any matter? The atoms which seem to describe the world are just stopping places on the way to something more basic, for which we don't have a name and for which we have no concept in our imagination. All we have is this bewildering equation which takes the two things that we thought we knew. We thought we knew what energy was, and we thought we knew what mass was, but it makes them, it equates them, and the exact relation, the principle of the equation, is something else again, the speed of light, which is also outside our experience and seems to be a completely different category of things. Why would you multiply stuff times a velocity in order to get power? That makes no sense. And why would that why would that velocity be multiplied by itself? We have a rationality and an equation, a thing for the mind, to which we can't put any definite concepts by our imagination, which has nothing to do with our experience. And it seems to explain the world, but without giving us anything solid to hang on to in place of the things that it took away. What it does promise is a kind of complete happiness, a complete satisfaction of our desires. But that makes the problem worse instead of better.